Hey, thanks for clicking on my video. If this video helps you, please consider liking this video and subscribing to my channel. It is greatly appreciated and it really helps. Let's get to the video. Hello everyone, in this video we're going to talk about some trigonometric sum and difference formulas. So we've got 3 on the side for sum formulas and 3 on the side for difference. So 1 each for sine, cosine, and tangent. So we'll jump right in, we'll talk through these 3 or 6 actually different sum and difference formulas, and then we'll do an example for each sine, cosine, and tangent. So for the left and right, we see the sum formulas. So if I have sine of A plus B, then we can expand that to sine of A times the cosine of B plus the cosine of A times the sine of B. For cosine of A plus B, maybe a little bit more straightforward. We have cosine of A times cosine of B minus sine of A sine of B. So I say a little bit more straightforward because we noticed for sine we had sine of A cosine of B and then cosine of A sine of B. So it seems like we're mixing sine and cosine there a little bit in terms of our multiplication. We do have, with our sum formula for cosine, we do have cosine and then sine, but like we said, we're taking the product of the 2 angles for cosine and then the 2 angles for sine. However, it gets a little bit tricky in there because we do subtract them on that sum formula. And then for tangent of A plus B, we have tangent of A plus tangent of B divided by 1 minus tangent of A times tangent of B. So those are our sum formulas that we'll be working with. We might not do an example for every single one of those, but we will do an example, 1 of each for sine, cosine, and tangent. Then we have some difference formulas, so sine of A minus B. So in this case, we would do sine of A cosine of B minus cosine of A sine of B. So very similar to the sine sum formula, and just instead of addition, we are subtracting. And then cosine of A minus B, same as our sum formula, but now we are adding instead of subtracting the products of cosine A and cosine B, and then sine A and sine B. For tangent difference formula, so tangent of A minus B, we're going to do tangent of A minus tangent of B in our numerator. So that's the opposite of what we did for the sum formula. We're going to subtract those. And now in the denominator, we still have 1 and then tangent of A, tangent of B, but now we're going to add 1 plus tangent A, tangent B in our denominator, okay? So as we're going through these 3 examples, I'll scroll back up and refer to the formula that we're going to be using so we can see where it's coming from and maybe help us to figure out which formula we should use, okay? So let's jump into our examples. So for example number 1, we have sine of 75. So if you notice for all of these examples, we are given an angle. For 1 and 2, we're given that angle in degrees, and then for 3, we're actually given it in radians. And we're going to take this single angle and we're going to separate it either into a sum of 2 other angles or a difference of 2 other angles. And when we do that, it will allow us to use the sum and the difference formula. Now let's think about what types of angles we would want to try and split our single angle into. Well, if we're taking sine, cosine, and tangent, then it would be nice if we could use our special right triangle measures. So like a 45, 45, 90 and a 30, 60, 90. So at the bottom of the screen, what you see here is I've drawn on those 2 special triangles, and I've also put in the side lengths and the hypotenuse length to kind of just on the base triangle there, so that we can use those values to find our trig ratios. So what we're trying to do is let's try and create 2 angles out of 75, 105, and then pi over 12 that would be either a sum of 45 and 45, or 45 and 60, or 30 and 45, or a difference, right? So we can use the special trig ratios for those special angles to help us use the sum and difference formula. So number 1, sine of 75. So for this one, let's think about 45 plus 30. So we could write it as sine of 45 degrees plus 30 degrees, okay? So now if we look back at our sine, this would be our sum formula. Then we need to do sine of A cosine of B plus cosine of A sine of B. Okay, so we need to do sine of 45 degrees times cosine of 30 degrees, and then plus cosine of 45 degrees times sine of 30 degrees. So now we're going to go down and refer to our 2 triangles here. So for 45, for sine and cosine, I'm referring to my 45, 45, 90. And then for cosine and sine of 30, we would refer to our 30, 60, 90. So sine of 45, opposite over hypotenuse, right? So 45 opposite over hypotenuse would be 1 over root 2. And we would rationalize that denominator to get a value of root 2 over 2. Okay? Now for cosine of 30, we'll come over to our 30, 60, 90. Cosine is adjacent over hypotenuse, so that would be times root 3 over 2. Now cosine of 45 is going to be the same as sine of 45, 1 over root 2, which would simplify or would rationalize to root 2 over 2. And then now sine of 30, we have opposite over hypotenuse, so this would be 1 over 2. And now we can just simplify what we have. So root 3 times root 6, or excuse me, root 2 times root 3 would be root 6 over 2. And then this would be root 2 over 2. So now we could combine those as one fraction and say this is root 6 plus root 2 divided by 2. And that would be our exact value for sine of 75. All right, so now for cosine of 105, let's think about two of those special angles that would come up with 105. So how about we do 60 plus 45, right? So let's say we did cosine of 60 degrees plus 45 degrees, okay? So we're still using a sum formula, I know that, but remember for cosine of our sum, we actually subtract there in the middle. And so that's why I wanted to use that one, because we can work on our subtraction here with this example number 2. So for this one, we're going to do cosine of A, so cosine of 60 degrees, times cosine of B, so cosine of 45 degrees, minus sine of A and times sine of B. Okay, so come back down, we're going to find cosine of 60. So we're at our 30, 60, 90 triangle adjacent over hypotenuse. That would be 1/2. Cosine of 45, we already found it on number 1. We said that was root 2 over 2. And then sine of 60 would be opposite over hypotenuse, so that would be root 3 over 2. And then sine of 45 we already found on example number 1, and that was root 2 over 2. So now once again we just multiply and subtract, so this is going to be root 2 over 2 minus root 6 over 2. Once again we have two fractions with the same denominator, so we could write them together as root 2 minus root 6 divided by 2. All right, and that would be our exact value for cosine of 105. And lastly, number 3, we have tangent of pi over 12. So now we're talking about radians. So if you'll notice down here, I made a little conversion chart for us for what the radian value is for these 3 special angles that we're trying to use, 30, 45, and 60. So pi over 6 would be 30 degrees, pi over 4 would be 45 degrees, and pi over 3 would be 60 degrees. So for this one, we're trying to take pi over 12 and separate it into a sum or a difference. So how about we do pi over 3 minus pi over 4. So we would have tangent of pi over 3 minus pi over 4. So now we're trying to, that value inside that difference there should be equal to pi over 12. Well, if we went over here to the side and said, okay, what if we wrote these as fractions with a common denominator? So it would be 4 pi over 12 minus 3 pi over 12, right? And that's what gives us our pi over 12. So we know pi over 3 minus pi over 4 would equal pi over 12, and we're good to go. So now we have a difference formula. So we're over here in the right column now, and we're going to look at our tangent of A minus B, okay? So now we're going to write tangent of A, so tangent of pi over 3, minus tangent of B, so pi over 4. And now we're going to divide that by 1 plus tangent of A, so tangent of pi over 3, times tangent of pi over 4. So now let's take a look at our right triangles down here, and let's look at what degrees we need. So pi over 3 and pi over 4 are 45 and 60. So we're focusing on these two angles here. So we want to do tangent of pi over 3, which would be tangent of 60. So tangent is opposite over adjacent. So in this case, opposite over adjacent would be just root 3. And then tangent of pi over 4 would be tangent of 45 degrees. So opposite over adjacent would be just 1. And then we have 1 plus, and then tangent pi over 3 we said was root 3. And then we're going to multiply that by 1. So this is going to end up being root 3 minus 1 divided by 1 plus root 3. Okay, so now we can't have a radical in the denominator, so let's rationalize this by multiplying by the conjugate. So let's actually come down here and let's say root 3 minus 1 over 1 plus root 3. Now we need to multiply by the conjugate of our denominator, which would be 1 minus root 3. So now the reason we do that is because that's going to get rid of our radical in the denominator, because we've created the sum and difference pattern in the denominator, which is just a squared minus b squared. So that's going to end up being just 1 minus 3, which is going to equal negative 2. Now in the numerator, we can FOIL. We have two binomials we're multiplying together. So that would be like root 3 times 1, so root 3. Root 3 times negative root 3, so minus 3. Negative 1 times 1, minus 1. And then negative 1 times negative root 3, so plus root 3. Okay. So now let's come down and simplify that because we're getting a little tight here to the edge of the screen. So notice we have root 3 plus root 3. So we'll write that as 2 root 3. And then we have negative 3 minus 1, which would be minus 4. And we're dividing this by negative 2. So now we could separate that fraction. So we have 2 root 3 divided by negative 2. And then we would have minus 4 divided by negative 2. So that's going to give us we'll flip the sides here. So negative 4 divided by negative 2 would be 2, and then we have 2 over negative 2, which would be minus, so this would be just 2 minus root 3, okay? And so that is how we can use some trigonometric sum and difference formulas to find exact values of sine, cosine, and tangent angle measures.